All right, 7.2, day 2. With the use of the calculator, these can be simplified quite a bit, but what sometimes you might want to do is actually switch the problem a little bit. Today's going to be the first day that we do not do dx on one of the problems. We're going to do dy. But we will start by doing it dx, and then I will show you why perhaps dy might be easier on some of them. So the first thing we're going to want to do is kind of figure out what's going on with this graph. You notice the x and y axis I've given you really not all that big. So basically we have the square root of x, and then we have x minus 2 is a line, and then also bounded by the x-axis. So let's go ahead and get a good graph for this. Let's see, I'm going from 0 to 2 and 0 to 4. All right. Was there anything in there that should have me check my mode? Anything in either one of those problems? No. And what would be something that would be in there that I should check my mode?
Sine, cosine.
Sine, cosine, exactly. You're probably going to want to be in radians for those. And what do we got there? Square root of x, I believe, is one of them, right? And the other one is x minus 2. And for a window, let's see. We went from, what, 0? Again, the only reason I'm picking these is because that's what was on the notes. X scale of 1, does that seem? Yeah, that's probably on it. 0. What was it, 2? X scale again. That seems pretty good. So there comes the square root of x. There's y equals x minus 2. And let's hope this works. You never know. All right. So here's your x-axis. There's part of it. And there's the other one. So that's what's enclosed. What you've been taught for finding area underneath the curve is basically to take the top one minus the bottom one, right? But unfortunately, that changes. I think that we can agree that the square root of x is on top the entire time. But on the bottom for approximately half the time is just the x-axis. And then it changes that this ends up being on the bottom. So what we're in essence going to do is we are going to split this on our own into two regions. For our purposes, we'll call it region A and region B and try and figure out those answers. Okay. For region A, we know that the square root of x is on top. We know that the x-axis is on the bottom, correct? So in other words, we could just integrate that one. And isn't that the answer it's going to get us? Because we're going to subtract 0 for bottom one. And so basically to do that one, it's from 0 to, now do we know exactly what that point is down there? Do we know for sure? Do we know that it is 2, 0?
Yeah.
Yes, we do. So we're going to go from 0 to 2, and we're just going to integrate the square root of x. Again, we are still doing dx with this problem. That is basically for region A, and I think you can all agree that would actually just give me the answer for that one. Again, if you want to put minus 0 in there, you can, but this one down here is 0. For region B, from where to where? 2 to 4. Again, that's because right here is 2, all the way over here to 4, because that's where they actually do meet, is at 4. It's what 4, 2 is where they actually hit right up there. Now, do they have to hit at nice points? That's another question. Not really. So 2 to 4. Well, which one is on top is still the square root of x. But now I have to subtract. Now, be careful how you write this. Subtract the bottom one, and we better use a different color. And what is that bottom one? X minus 2. So this top one, you could almost figure that out right here where we're at. And just use the calculate, right? You could just figure that out from here. This one, you might want to clean this one up and then redo that one. Okay, that's completely up to you. Or you could find the two separately, but I think it's probably in your best interest to clean that up first, regraph it, and find that area. Okay? Or you could always go to that other place where I showed you where you can enter the equation and go from there. Is there a whole lot of cleaning up we can do on this bottom one? But the only thing we can do is distribute the negative. Okay? So why don't you go ahead and figure this one out now? Because that's one that you can do right from the screen that you have. You just basically go from 0 to 2, and it should calculate that for you. What'd you get for A? 1.89 if you round it right, so 1.8856-ish. Has anybody been able to get the bottom one yet? Have you had enough time? It's about 1.4, yeah, it's about 1.414 for the square root of 2 for those that are looking for that. Remember, you would have to integrate it if you did it by hand first. And I could always have you do that. Positive, yeah. If you do that one, it's about 1.4477. So if you add A and B together, you get approximately not too hard. Add those two together. 3 point, a lot of threes, right? It's about 3 1/3. Now, I was glad that someone mentioned an alternate method this one could be solved. Would anybody like to share an alternate method they came up with for solving this particular one? Yes, please. Okay. What was said is, why don't we find the area of the top one from 0 to 4. Now, this is interesting how the calculators are going to deal with this. Do you have to get rid of this other line to do that? Or will it do it for you, is the question. Okay, so let's try it right now. Let's try and find that one from 0 to 4 and find out. It does do it all. So it's 5 and basically about 5 1/3. Correct? Now what we're being told then, and I hope this works. Nope. So that was about 5 1/3. But we don't want all of that. Yeah, minus the triangle. Now, are you always going to have a triangle? No. But could you then just graph that and find that area if you wanted to? Yes. So we said the whole thing was what, about 5 1/3, and what's the area of that? It's 2 by 4. So it's 2. You subtract that out, do you get the same exact answer? So both ways work. That's good. Look at the problems, find other ways of doing them. Do you have to understand exactly what the antiderivative is doing to do that? Yeah, you need to know what the antiderivative is actually doing. It's finding the area underneath that curve. So very good. Now, this is going to prove important, what I show you next. We could do the same thing, doing it slightly different. The reason these were considered dx, remember back to the rectangle days, when we did a bunch of rectangles in here? All of the rectangles came down here, which is dx. which means with respect to the x-axis. That's why we brought them down there. We're actually going to do this one, dy, which means the rectangles go not up and down, but side to side, for example. Rectangles are going to be going this way, which makes it a dy, because they are going this way. So some people have to turn their heads. If you go to the y-axis, which one's actually on top, or which one's furthest from the y-axis? The square root of x or the y equals x minus 2? Y equals x minus 2 is. Well, let's see what we can do then. So that one we already did. On to this one. Right, give or take a little bit. That's what we've got. Well, we go, it's y equals the square root of x, and y equals x minus 2. That's what they look like when I do dx, correct? What do you suppose I have to do to make it dy? I need y to be the variable that's kind of inside. So I have to solve both of these differently. Right now they're solved for y, agreed? When they're solved for y, you can do dx. So for dy, I need them solved for x. How do you solve this one for x? Not square root, but square both sides. So do you agree that x equals y squared is the same exact thing? And this one is x equals y plus 2. Which one of these over here is the x equals y squared? Yeah, this one right here, right? Here's x equals y squared. And here is x equals y plus 2. This is going to end quicker than you think. Now, the reason the other one was kind of tricky, and obviously I could have made it harder, but the one that was on top, or actually the one that was on bottom, switched when we did it the other way, correct? Again, if you turn your head, does the one that's on top switch? I mean, as far as throughout the entire problem? Or is it always y plus 2, the one that's on top? If you turn your head. I'd say y plus 2 is always on top, isn't it? So what we're going to do, we're going to integrate. Y plus 2 is on top. We're going to subtract the one that's on the bottom. What do we know that as now? Again, this one's on top. What do we know the other one as? We know it as y squared dy, and I'm going to be very interested what you tell me to put there and there. If you can tell me the correct numbers, I think you understand. 0 and 2, very good, because we're doing y-axis, 0 to 2. Excellent. Seeing this is the first day you've seen dy, you're off to a very good start. But how do you put y into your calculator? Yeah, just make them x's, exactly. Just make them x's and do 0 to 2. It's going to work out. It's not anything different. Okay? But I will show you this. If you're finding the area of this one right here, you basically just found all of that. Finding the area of the other one is subtracting that stuff out, which is what you want to do. Okay? So go ahead and solve that one now. Again, you can just put x's in instead.